works is that we have a what you call a ready queue and we have a running queue. So in the ready queue, processes come and it waits for the process to finish, which is running in the what you call running queue. Okay. So first we'll just check this function, find waiting time. So what I did here was initialize a array burst remaining burst. So what happens in the round robin algorithm is that since it's a preemptive algorithm, the burst time basically will keep getting decremented. So we want to see how much burst time is left for each process. So what I do initially, I have them all equal to the current burst time, like the burst time that we will get from the user, and I put it through this while equals true loop. So this will only get out of this loop once all of the processes are completed. Now this done is just a what you call a flag that I put in case one of the processes finish, and I create a loop from 0 to n, where n is the number of processes. And now I check if my remaining burst time is more than 0. So if my remaining burst time is more than 0, it means the process is not completed, and I go inside, and that means it's not done. If the process is not completed, it's not done. So now I check the quantum window. So the quantum window is how many time steps should the process run for. So if it's greater than the quantum time step, let's say the process needs to run for 10 time steps and the quantum time window is 3 time steps. That means this is greater. So we will go in this if condition. And all we'll do is we'll add the time step to the quantum and we'll reduce the remaining burst time. So let's say it ran, quantum was 3 seconds. So it would run for 3 seconds and then it would go back, this process would go back to the ready queue. And now my voice is going. Hello? Okay.
Yeah, continue.
Okay, yeah. So now, okay. Next, if let's say the remaining the burst time is actually less than the quantum. Let's say only 2 time steps are remaining for the remaining burst time, but the quantum window is 3 seconds. So it will actually go here, and we'll just add the remaining burst time, which means only 2 seconds will be added onto the time, and the what WT is the. So now the remaining burst time is 0. Now if all of them are done, then we just simply break this complete loop. It means we're done with processing all of the waiting times. So we've calculated all of the waiting times using this function. Now we have to find the turnaround time. So the turnaround time formula is simple. It's burst time plus waiting time. So I just took one for loop and it just calculates it for every single process. And now to find average time, all we have to do is we have to see the total number of processes, add it to the total, add the total waiting time, add the total turnaround time, and then we can find the average time by dividing it by the total number of processes. So total waiting time upon number of processes, total turnaround time divided by number of processes. Main function is pretty simple. We just take the input of the user, how many processes there are. Then here we take the burst time. Each of the burst times we ask the user, please enter the process burst time, and we enter the quantum window. So and then we can call the find average time function. Find average time function will implicitly call waiting time function and turnaround time function, and it'll print the average in this, and the output looks like this. Yeah, that's it.